June 15th, 2025 at 12 o'clock at night, if you look southeast, you will see the Scutum constellation without a telescope just rising in the dark. You know, what's the weirdest thing about this constellation? Well, an Australian research team scanning the night sky discovered something completely impossible. They were tracking common cosmic objects that emit radio waves like neutron stars, pulsars, or their hypermagnetic siblings. But instead, they picked up a mysterious radio signal blasting directly out of the Scutum constellation. It didn't match any known object in human history. And you know what's worse? This signal kept flashing continuously for about 5 minutes, suddenly disappeared, and then came back exactly 22 minutes later. In the silent, vast stretches of a galaxy, something is ticking. For decades, it went unnoticed, a rhythmic pulse lost in the static of the cosmos. But in 2022, a strange new radio signal was found arriving every 22 minutes, and it was discovered not by a career scientist on a government mission, but by a college student. Tyrone O'Doherty, an undergraduate student at Curtin University in Australia, was sifting through old data of the southern sky for a school project when he stumbled upon a weird blinking radio signal from 2018. It behaved like a lighthouse beam shooting toward Earth. Excited, he shared it with his mentor, radio astronomer Natasha Hurley Walker. As they investigated, they found a pattern. The first signal repeated every 18 minutes, but then it vanished after only 3 months. While searching for more, a new signal popped up. This one blinked for 5 minutes, disappeared, and returned exactly 22 minutes later. It was named GPM J1839, and it was about to challenge everything we thought we knew about the life and death of stars. Finding a repeating signal is huge, but identifying its origin is harder. Astronomers began digging through 35 years of archival data. To their shock, they realized this signal wasn't new. American and Indian telescopes had caught it as far back as 1988, but it had remained buried under a mountain of data for decades. The source is located roughly 18,000 light years away. What makes it truly baffling is its stability. Most pulsing objects in space, like pulsars, slow down as they age and lose energy. But GPMJ 183910 has remained virtually unchanged since more than 3 decades. By averaging 35 years of fluctuations, scientists calculated that the source rotates once every 21 minutes and 58 seconds. Over that entire 35-year span, its rotation hasn't increased by more than 0.28 milliseconds. For an object rotating this slowly, that level of mechanical certainty is scientifically odd. It is behaving like the finest clock in the universe, yet it shouldn't have the energy to keep ticking. If GPMJ 183910 is what scientists suspect, it's a neutron star, the leftover heart of a dead supergiant star. To understand why this 22-minute pulse is a problem, we have to understand what a neutron star actually is. Aside from black holes, these are the densest objects in the universe. A normal atom is 99.999% empty space, but in a neutron star, gravity has crushed that empty space out of existence. Protons and electrons are squeezed into a solid sphere of neutrons. A single teaspoon of this material would weigh as much as 11 times the entire human population, roughly 88 billion tons. This extreme density creates an incredibly powerful magnetic field. This field is the engine for the radio signals we detect, but the physics of how that light is actually created is a violent, complex process. So how does a dead star shoot radio waves 18,000 light years across space? It starts with a single electron near the star's magnetic pole. Accelerated by the magnetic field, this electron emits a curvature photon. This photon travels until the angle between its path and the magnetic field reaches a threshold. At that point, the light dissipates and creates a pair of particles, an electron and a positron. These particles then release synchrotron photons, which create even more pairs. This is a pair production cascade, an exponentially growing shower of light and matter. This cascade is what makes the light intense enough to be seen from Earth. Because the star's magnetic poles aren't aligned with its rotation axis, it acts like a giant lighthouse. As it spins, the beam sweeps across our telescopes once every rotation. The signals from GPMJ 183910 show the exact hallmark signatures of this process. They are polarized and show sudden 90-degree swings in that polarization. But there's a fatal flaw in this explanation. Pulsars survive on energy. As they shine, they lose energy and their rotation slows down. Eventually, they slow down so much that they can no longer power the pair production cascade. When the energy drops too low, the lighthouse turns off. Astronomers plot this on a graph. Any pulsar that falls into the gray band in the middle is in the death valley. Most pulsars we know spin between 10 times a second and once every second. GPM J1839 spins once every 1318 seconds. It is way beyond the death valley line. According to every model of physics we have, this star should be dark. It should be dead. Yet it has been shouting into the dark for at least 35 years without slowing down. Scientists are left with a match not found message on their screens. If it's not a standard pulsar, what is it? Some think it's a magnetar, a neutron star with a magnetic field 10,000 times stronger than normal. Magnetars have starquakes that release massive energy. But starquakes also emit X-rays, and we haven't seen a single X-ray from this source. Plus, starquakes usually fade in a few years, not 35. The final natural theory is a dwarf pulsar. This would be a highly magnetic white dwarf, the leftover of a smaller star like our Sun. White dwarfs are less dense and can rotate slowly while remaining stable. However, GPMJ 183910 is 1,000 times brighter than the only known white dwarf pulsar, ARSCO. And what about life beyond Earth? Some believe this could be the signal the SETI project has been waiting 50 years for, a communication from another civilization. While exciting, most scientists lean toward a natural explanation we simply haven't named yet. We also detect thousands of fast radio bursts, FRBs, every day, which are even more powerful, releasing as much energy in milliseconds as our sun does in 3 days. The universe is full of loud, mysterious voices. While the lack of an answer is frustrating, it's also the most exciting part of astrophysics. When data breaks our theories, a revolution in understanding is usually right around the corner. Astronomers are now searching through years of collected data, convinced that most signals like GPMJ 183910 are hiding in plain sight. Finding them will help us map out what truly happens to stars after they die. Until then, the 22-minute pulse remains a lonely, rhythmic reminder of how much of the cosmos is still waiting to be discovered. Now, here's the big question. Could this mysterious signal actually be coming from another civilization? Share your theory in the comments below.